this video, we will discuss the SaaS technology stack for an architecture on AWS. So in order to build a multi-tenant architecture, you need to integrate the correct AWS web stack, including the OS language, libraries, and services to the AWS technologies. And this is the first step toward creating the next generation multi-tenant architecture. And in case you haven't chosen your web stack, I would suggest to you the perfect AWS SaaS tech stack article. And even though we will surface a few other multi-tenant architecture best practices, this article will primarily orient towards this AWS SaaS web stack. So let's dive deeper into our SaaS technology stack on AWS. Programming language. It doesn't matter which programming language you select, but it's vital that your application can scale. Use the multi-tenant architecture best practices, cloud native principles, and a well-known language by the open source community. So the latest trends tend to be Python React in AWS or Node.js React in AWS, perhaps Node.js Angular in AWS. But in the end, the common denominators are always AWS and React, or one of the other common frameworks for front-end are Angular and Vue. Now, if you are a financial company, machine learning, or AI with complex algorithms or backend work, I'll say you should go with Python. If you are a regular, maybe chatting or education or gaming or other types of things which you tend to do, which are more service-oriented than computation-oriented, then you may want to go with Node.js. Okay, so you can go with real-time chats, mini feed, streaming, etc., then go for Node.js. If you want to learn more about this, there's another blog called Basics of Multi-Tenant Node.js and PostgreSQL, where you'll find valuable information about this topic. There's a market in the banking sector that's leveraging Java. That's for established enterprises. There's also a lot of traditional enterprises which are using PHP. Now, any new SaaS application is better done with the more modern web stack of using Node.js or Python along with React or Angular and AWS. And there's also, of course, Google Cloud if you prefer that over AWS. Now, from my personal experience, I can tell you that if you have very predictable user growth, then just getting your own VMs and dedicated servers can be cheaper. But if you have an application which can go viral and get sudden rapid growth, then something like AWS can help you scale better. Now, on the back end, you can also be using Go or Java if those are your interests. Next, for the cloud provider, most DevOps choose AWS, but like I said, there's also GCP, Azure, and DigitalOcean, that you have some choices there for your cloud provider. Okay, and the person that wrote this blog is recommending AWS because it has a number of benefits, like every day there's a new service available to you and a new feature that facilitates your development and deployment, and totally recommend to deploy your SaaS on AWS. All right, so that seems more of an advertisement, but it's also somewhat true. So next, let's talk about microservices. If you're planning to leverage the cloud, you must leverage cloud native principles. One of these principles is to incorporate your microservices with Docker. And make sure that your SaaS application is under microservices, which brings multiple benefits, including flexibility and standardization. Makes it easier to troubleshoot problems, isolation, and portability. And so just like cloud, Docker and microservices have transformed the IT ecosystem and will stay for a long while. Just in case you don't know what Docker is, it essentially packages your application along with the environment into a container. So Docker basically is a containerization. And the benefit of this is, for example, if you were doing something in Python and you were using Python 2, and the particular server had Python 3 installed by default, your application wouldn't break because the Docker container would contain the Python 2 environment for your application. So containerization ensures that you have the appropriate environment and environment variables to go along with your application that are deployed, and makes the server environment agnostic. Okay, so let's talk about the container orchestration platform, where you can use a few different things with AWS, which obviously the person writing the blog is most familiar with AWS, and so they're talking about the Amazon services. And there are 3 options in AWS to manage, orchestrate, and create your microservices cluster environment. And so before the explanation, he wants to recommend you this article on ECS versus EKS to help you make the right decision. EKS basically stands for the Kubernetes cluster, and ECS is your container orchestration system. So C is for container and K is for Kubernetes. And so Amazon ECS is Amazon's Elastic Container Service. It's a natural Amazon container orchestration system. So essentially you have Docker containers, and your ECS orchestration system will move these Docker containers around into the correct servers and deploy them for scalability, right? So ECS is highly recommended for startups, small SaaS, and medium SaaS. Then there's Amazon Fargate. Almost serverless, price and management is per task, and minimal operational effort versus ECS. And there are some studies conducted by the DevOps team in terms of performance. Fargate can be slower than ECS. And so for this particular case, Amazon ECS is recommended instead of Fargate. Another thought is that if your team is pure developers and not planning to hire a DevOps engineer, then perhaps Fargate is the way to go. So this is basically the trade-off here is, if you have development expertise in DevOps, then you should do ECS. And if you're willing to accept a little bit slower application, and you don't want to have DevOps resources, then Fargate can be the way to go. Now, Amazon EKS, which is a Kubernetes service, is for larger, more sophisticated applications. It's a managed service that makes Kubernetes on AWS easy to manage, and it essentially deploys a Kubernetes cluster on an EC2 instance, and sets up the Kubernetes networking and various worker nodes. This is good for large SaaS applications and sophisticated DevOps and web development team. For further information, you should read about the best practices for EKS. There's another blog link here for Kubernetes multi-tenancy SaaS application with Amazon EK. Okay, so which is the best? What shall you use? In this blog, I'll explain the main differences, pros and cons of the Kubernetes versus ECS, which is best container orchestration. Okay, so let's move on. I'm assuming that if you're reading this article, and unless you're working at a large company, you would, in that case, probably already know. But if you're doing a startup or something, ECS is probably going to be your choice. So, database, the inherent database will be PostgreSQL with Amazon RDS. However, I strongly recommend that if you have a senior development team and are projecting a high traffic for your SaaS application, or even hundreds of tenants, then you had better architect your database with MongoDB. In addition to this, use the best practices that will be mentioned below about multi-tenant database. In this case, I would go for Amazon RWS with PostgreSQL or DynamoDB, which is basically MongoDB. So once again, I think this person has very strong opinions. I think databases like MySQL and Oracle also work just fine, but this person is very opinionated about MongoDB, so I think that has issues, but that's a separate discussion, so I'll leave that to you. If you're projecting a high traffic, so this person basically has a very strong database preference towards MongoDB. I think there's also other database systems. You should consider the right database system for your application. GraphQL or Amazon AppSync are other options as well. GraphQL is a query language and an alternative to the RESTful API for your database services. This is new, and modern ecosystem is adopted as a middleman among the client and the database server. It allows you to retrieve your database data faster, mitigating the overfetching in databases, retrieve the accurate data needed from the GraphQL schema, and maintain mainly the speed of development by iterating more quickly than a RESTful service. So adopting a monolithic backend application into a multi-tenant microservice architecture is the perfect time to leverage GraphQL or AppSync. So basically, if you're shifting a monolithic backend application into multi-tenant, that would be the time you want to go for GraphQL or AppSync. Kind of like what Facebook had ended up doing at some point. And so transforming your SaaS application, don't forget to include GraphQL. Now, he makes a note that he didn't want to include the service in the AWS SaaS architecture diagram because it's implemented in multiple ways and would require a separate in-depth explanation of this topic. All right, let's talk about automation. So you need a mechanism to trigger or launch new tenants and organizations and attach them to your multi-tenant SaaS architecture. So you should create some sort of scripts or Jenkins job or something to basically go ahead and trigger those kind of launches. Now, let's say you have new client that just subscribed to your SaaS application. How do you include this new organization in your environment, database, and business logic? So you need to have that process together to launch the new tenants. And that's called infrastructure as code, IAC. So this script or procedure should live within a Git repository, one of your fundamental DevOps principles, and a strong argument to leverage automation and IAC is that you need a mechanism to automate your SaaS application and for your code deployments, and in the same lines, automate the provisioning of new infrastructure for your dev or test environments. Right, so that's what we're going to say about automation. Now, infrastructure as code and automation tools. It doesn't matter which infrastructure as code tool to use. They are both useful. Terraform and CloudFormation, they both do the same job and are highly known by the DevOps community. And I don't have a winner, but they're both good. And however, if you want to know more about the advantages and disadvantages, there's a recommended blog. We will see over time if one of them starts to win out. But essentially, you have Terraform and Amazon's CloudFormation as your. Terraform is by HashiCorp as choices to do this type of automation. Next, we have message queue systems, MQS. These are common RabbitMQ, Celery, or Amazon SQS. You should use the one that requires you less operation. So Amazon SQS is the one being recommended here, but you can use the other ones if you're familiar with them. There are multiple times that you need asynchronous communication from delaying or scheduling a task. to increasing reliability and persistence with critical web transactions, decoupling your monolithic or microservice application, and most importantly, you want to use a queue system to communicate event-driven serverless applications, Amazon Lambda functions. So as you can see, this is definitely, the person writing this article is very deeply involved in the Amazon infrastructure and ecosystem, so that's why they're tending to recommend Amazon SQS as the choice. Caching system, again, they've chosen an Amazon caching system, which is the Elastic Cache by AWS, and it can help you with caching and data storage system that's fully scalable, available, and managed on Amazon. It aims to improve the application performance of a distributed cache, data, and in-memory data structure stores. It's an in-memory key value store for Memcached and Redis engines. With a few clicks, you can run this AWS component entirely self-managed. It's essential to include a caching system for your SaaS application. I personally just like to use Redis if I'm using Node.js or something very directly. And if I was using PHP or something of that sort, then Memcached, of course. And next we have the cloud storage system, which again, Amazon S3, Amazon Cloud Frontend CDN for your static content. I like to use Cloudflare for my CDN. There's also Akamai I can mention that is very popular for the front-end CDN when you're building architectures. So all of your static content, images, media, HTML, all of these things are cached by the CDN and distributed around the world so that your users can quickly get these things. And the cloud system has infinite storage and elasticity. I mean, we all know that in reality it's never infinite, but a large amount for whatever you will be needing. Now, in front of this Amazon S3 will be the AWS CloudFront, integrating this pair of elements in Vital and in order to cache the entire static content and reduce your bandwidth cost to your actual server. So like I mentioned, this article only mentions Amazon S3 and CloudFront, but you can also use Cloudflare or Akamai or some other CDN as appropriate for your business. So next we are talking about the SaaS web stack, multi-tenant SaaS architecture example on AWS here. So let me see if I can zoom in a little bit onto this one. Okay. Cool. So here you can see that there is on the left side a panel with the CI/CD pipeline, in the middle the AWS cloud, and on the right side the infrastructure management. And at the top you see the user devices that are connecting through the internet. So that's essentially the internet is connecting to your CDN, which is then connecting to the S3 media, which is all the images and HTML and things that were cached. So let me use the mouse pointer here. So here's your S3 media, which is essentially feeding into your front-end distribution of your CDN, the CloudFront distribution in this case. And the other piece is the application load balancer. This is the public subnet. So your application load balancer is talking to your EC2 instances, as well as to your Terraform, which can help you launch the new tenants. So when you launch a new tenant, you're going to want to let the load balancer know about that tenant as well. So this Terraform, the code that does the deployment, as we talked about, is basically in GitHub and is managed by the DevOps team. On this other side, in the CI/CD pipeline, you have the other developers of the actual SaaS application who are deploying their code to GitHub and deploying it using their build pipeline through Jenkins, or which is the most common build tool, or whatever else you might be using to deploy your builds. So this code is being packaged as Docker images in the pipeline and then being deployed over into your EC2 instances as the different microservices. So here you can see the ECS cluster where you have the different microservices replicated across the different EC2 instances, talking to the load balancer, talking out to the cloud for distribution, right? And you also have a message queue for events that is sitting there, which could be Kafka or SQS or that kind of thing. And then you have your private subnet with your database and elastic cache. So here you have whichever database system you've chosen. This person's chosen PostgreSQL, but you may have Mongo, MySQL, Vertica. There's a whole host of database systems that could be in this layer here. So this is essentially the overall architecture that we have at this point on our AWS system. So in the next video, I will discuss the types of multi-tenant SaaS architectures, and yeah, let's see you there.